So we solved one problem yesterday. So again, level similar problem on assignment at the so this problem was pretty much the procedure was pretty much straightforward. So basically, the idea is first you have to draw the free body diagram, then you have to draw the idealized free body diagram, then use Lamis theorem or whatever theorem you know to solve. Okay, so equilibrium is an important concept. You should know what is an equilibrium. Equilibrium means the resultant of all the forces should be equal to 0. Now, after that, then we also solved. We were trying to solve this problem. Okay, now was anyone able to solve this problem? Did anyone try? Did anyone try to solve this problem? Okay, so my question was, find the force F that is to be applied so that the block is in equilibrium. Maybe block equilibrium. That means it is not moving. Okay, so what is the force that you have to apply? Okay, also find the force in the road. Okay, road also will take some force. Some force will be. But you can imagine this also. Some force will be taken by the road. You have to find that value also. Okay, then I told you this is pinned here, so I showed you what is a pinned connection or example. So this is pinned here. That means it is free to rotate. This road is free to rotate like this. Okay, if roading in so if it is pinned here, it is free to rotate like this. Right. Okay. Now C is a pulley which is frictionless. Okay. Now how do you solve this? It's fairly it is straightforward. Procedure Broadway now it's very simple. What you have to get the force like this. Okay. What is the total direction of forces? You know one force. Can you find other forces? That's all. Right. So let's see what is what will be these forces. Okay. Now this is F. Okay, this is a force on the string. This is force the force by the string on B, and this is a force by the string on point B, and this is a force by block on the force in a direction. So now the only thing that I have to get is I have to get this value. I have to get this value, this angle. Okay, the angle between these two, and I have to get this angle. So you can use Lamis theorem to solve this. Okay, now how do you solve this? So let's solve this. So the idea is to find the angles. So let's see what all we can do. I know this is 30 degree because this is given as 30 degree. This will be 30 degree. Okay, this is 60 degree and this is 90 degree. Okay, because it is straight line. Now I want to find theta. How do you find theta? So it is fairly simple. The total height is given as 6 meters. The total height is 6 meters. So 6 meters, what will be this height? Can I get this height? So this height is simple. If you see, if you look at the triangle, so this is one triangle, that is AB. Then I have a dotted line here. Then I have a dotted line here. Okay. Now this is A, this is B, and this is 5 meters, as I told you. This is 60 degree. Now, if this is 5 meters, what will be this height? And this is 60 degree. So this will be 5 cos 60. What is 5 cos 60? So what will be 5 cos 60?
2.5.
2.5. Okay. 5 cos 60 is half. So this is normal. So this is 2.5. Okay. What is this distance? This is 5 sine 60. What is this value? What is this value? So somebody calculate and tell me the value.
4.33.
4.3.
Okay, thank you. 4.33. Okay, so this is 4.33 and this is 2.5. So this question mark I can remove and I can mark this as 2.5 meters. If this is 2.5 meters, what is this height? Remaining height. What is remaining height?
6 minus 2.
Yeah, what is that?
3.5.
3.5 meters. Okay, so this is 3.5 meters and this is 4.33 meters. Okay, now if I take tan of theta, if I take tan of theta, what is tan of theta? 3.5 by 4.33. Now what is theta? Tan inverse of 3.5 by 4.33. What is this value? In degree, what is this value? So learn to use your calculator. Scientific calculator using a particular. I don't know. Do you have a calculator like this? This is my calculator. So you can see tan here. Tan and do that. So in my calculator, if you see,
Sir, 17.1.
How much?
17.1.
17.1 degree. Is it right? Will you get the answer?
Yes, sir.
38.94.
38.94.
38.94
38.
38.
38.94.
Okay. So degree, I know you have to check that. 38.94. So this is correct. Okay, that's 70 in the. So this calculator, I hope you know how to use this calculator. Otherwise, I think I have a video. Simple maybe first time using the. So generally these calculators, then a button there will be some numbers. So there is a set of normal numbers here. Okay. Then there is some special functions here. Okay, special functions in the calculator. Red, black, something is written. Okay. For a values to calculate. Some other color on the body there will be something else written. Okay. So our functions invoke here you have to use shift. Shift. Okay. So check your calculator. So the calculator I think I will send you a YouTube video so that you can understand. Okay. So that will be easier to see. So this is the 38.94. Now, okay. Now this, what is this angle? This angle is basically angle between this force and this force. So that is nothing but 60 plus 30 plus 60 plus 30 plus theta. Angle 38.94. What is this value? 90 plus 38.94. How much is that? 128.94 or no? No. 128.94. Okay, so that's okay. So this angle is this. Now what about this angle? Can I find this angle? So what is that angle I'm asking? And so this is the force. This angle is what I'm asking. So is there any way I can find that angle?
180 minus 60.
Yeah, 180 minus 60. Yeah. So the logic behind that is this: if this is 60, this is also 60. Okay. Well, if you see this vertical angle, this is 180 minus 60. Yeah. So that is the angle that is 120 degrees. Now we can easily find this angle. And then angle. This is 360 minus 120 minus 128.94. How much is this? Atrayana?
Sir, 111.06.
Where different angles marks you have to tell me, okay? Where are the answer? So I'm just taking values from you. Okay. Now can we solve this? Can people tell me what is the value of f? What is the value of FAB? Prayo. So use Lamis theorem and I'll give you 5 minutes. Okay, use Lamis theorem. Use Lamis theorem.
Sir, ഇവിടെ kilonewton തന്നേക്കണ അത് convert ചെയ്യണ്ടേ Newton ലേക്ക്?
No. In kilonewton ആണെങ്കിൽ this force also will be kilonewton.
Okay.
If this is kilonewton, then whatever values you are getting will be in kilonewton. Don't worry.
Okay, sir.
So what is Lamis theorem? So this like Lamis theorem also. F upon sine of opposite angle should be equal to FAB upon sine of opposite angle 128.9 should be equal to 1000 upon sine of opposite angle. Okay, so these are the. So take these two. If you use these two equations, what you will get? You know this, you know this, you know this, you don't know this. You can solve this. Then you take this and this, or this and this. Then you know all these three. Then you know this. You should get the same answer. What is the value of f? What is the value of f?
So is the weight 100 or 1000 kilonewton?
It is the question. How much is given? Okay, it is 100 kilometer. Sorry. 100 kilometer.
92.8.
Okay, Anna, your sound quality is not proper. What you do? You put it in the chat. Chat it. Sanjeev Harishankar, please mute yourself. Sanjeev Harishankar. Yeah.
FAB is
Asher,
to 83.34.
So Asher is telling me FAB equal to
83.34.
and
So F is
Normal
equal to
force,
92.8.
92.8. 2.8.
kilometer.
80. Yes.
Okay, so this could be correct. Okay, now how do I check whether it is correct? You can do many things, but we will not go into that. I think this is one way of doing it. Another way of doing it is again there is another way of doing this entire problem. I'll just show you how to do this. I'll say because you know this. Okay, so I'm just duplicating this page and I'm going to rub these things off. Okay, so this is the notes again. So this angles and all we have found. Okay, what we have, we know that. Okay. Okay. So let's say this is my FAB. As I told, this is F, and this is 1000. Also 100. Okay. Now I'll draw horizontal and vertical lines through B. this is my axis. Okay. So then what I will do, I will find these angles. Okay, so this angle I already know it's theta. We already found theta. And this angle, I don't know what is this angle. This angle no about 30 degree. Hello. This is the 90 angle. This is 30 degree. Okay. Now if I do this, this could be a slightly simpler formula. This also is okay until unless Lamis theorem you can do any method. Okay. So it is in equilibrium. As B is in equilibrium. So this is what I said yesterday. Method of projections, components. Okay, equilibrium. Summation of forces, all the x component of forces should equal to 0, and summation of all the forces y component should be equal to 0. With the next component in the FAB cos 30 degree in positive direction. So this I will take x in our this is positive, y in our this is positive. Okay, this is positive, this is negative, this is positive, this is negative. So FAB cos theta in positive direction minus F theta is 39. F cos 38.94. 94 should be equal to 0. Okay, so F cos theta on a distance. So what is F cos theta? F cos theta, where theta is 38.4, and this distance is FAB cos 30, like E distance. Now vertical distance is this sine. So if the vertical sum of the vertical components of the forces. So E force in a horizontal component because it is vertical. Okay. P force in the E force in we will see vertical. If you see vertical components, FAB vertical component is this. That is FAB sine 60. F in the vertical component is this. So that is F sine theta. So the theta is 38.94. Then we have W. Okay, so that means up is positive. So what we have two positive forces. FAB sine 60 plus, so this is a positive plus, then plus F sine theta. F sine theta is 38.94. That is plus. Then we have a minus 100 equal to 0. Okay, so we have two equations. You just solve these two equations. So when you run the equation solve it and cancel it. So I would say solve it. Let us see if it's matching. Okay, so what you have to do, you have to solve these two equations. Lead equation on the and have another equation. Okay, so this 100 I can take the other side. Okay, then find the substitute all those values. Then get under equation. As you are done, FAB F in the value calculate. This here is another. Try to solve this, okay? Okay, let's solve this. Now, what is cos 30? Cos 30 is 0.866. So this gives me 0.866 FAB minus what is cos? So cos of 38.94. 0.777. 0.777 F equal to 0. Sin 60 is half. Now sin 60 is sorry root 3 by 2. Okay, so root 3 by 2 is 0.866. 0.866 FAB plus sin 30 0.628. 0.628. FAB cos 30. FAB sin theta. This is sin 60 and 30. So this is 30. Yeah, and FAB sin 30. So this is 30. That's half. (0.5) FAB plus 0.628 into F equal to 100. This solved here. How do you solve this? Okay, so multiply this by 0.5, or let's say multiply this by 0.628 and multiply this by 0.777. Then you add this two. Then to add here. Open the 0.628 into this. This is a minus sign. 0.628 into this with a plus. This will come same. Then this will cancel out. So what you get? 0.866 times 0.628 is 0.54. 543 FAB minus 7 times 0.488 0.488 F equal to 0. Now this is .388 FAB plus 0.488 F equal to 77.7. You add these two, so this gives me. So these two will get cancelled. 0.543 plus 0.388. 0.931. FAB equal to 77.7. So FAB is equal to 77.7 divided by 0.931. So this gives me 83.45. Okay. This we got FAB. Then you lay the equation out, you just substitute that FAB's value. Then you will get the other value. So I can use this equation. So that is 0.866 FAB. So this FAB I will substitute as 83.45 minus 0.777 F. So equal to 0 means I can transfer it here. So this gives me F equal to F in the value I'll get. If we calculate, you should get 92.8. Okay. Something around 93 of it. Okay, just round the keyboard something around 93. Right. This is 83.4. Push the clear at it. Okay, so this is another way of doing it. More or less same answer we are getting. Decimals and issues are acceptable limits. Okay, 83 and 3. These two. Yeah. So this is two different methods of solving it. Any two methods, as you are comfortable, you can solve. Until and unless you problem Lamis Theorem use Lamis Theorem. Okay. Now we will start a new topic. Moment of a force. Okay, so moment of force means so basically this is a concept that you have studied in your physics in your +1 and +2. Okay, so basically if there is a force, okay, I can find moment of this force about any point, any random point, Okay, now how do I do that? So moment of a force we can calculate in two ways. One is for simple cases. It is force times perpendicular distance. Okay, now simple case എന്ന് പറയുമ്പോൾ വളരെ simple ആയിട്ട് ഈ ഫോഴ്സും perpendicular distance ഒക്കെ കിട്ടുന്ന കേസുകളാണെങ്കിൽ okay. For complex cases r cross x, okay, ഇങ്ങനെയാണ് മൂവ്മെന്റ് കണ്ടുപിടിക്കുക. സോ ആർ ക്രോസ് എഫ് എന്ന് പറയുമ്പോൾ ഭയങ്കര ജനറലൈസ് ആയിട്ട് നമുക്ക് ഫോഴ്സും ആറും വെക്ടർ ഫോമിൽ എഴുതി കഴിഞ്ഞാൽ യു ബ്ലൈൻഡ്ലി യൂസ് ദിസ് ഫോമുല, യു വിൽ ഗെറ്റ് ദ ഫോഴ്സ്. ഓക്കെ, സോ ഇൻ ആർ ഷുഡ് ബി സം ലെറ്റ്സ് സേ RA I cap plus RB J cap plus RC K cap, മൂന്ന് കോമ്പണന്റ് ആയിട്ട്. F also should be FA I cap plus FB J cap plus FC K cap. Okay, അപ്പോൾ അങ്ങനെ you will use vector multiplication, cross product. Okay, so we will take this up later. First we will understand what is a moment of force. Okay, and where can we apply that? Moment of a force is basically so എന്താണെന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ നിങ്ങൾക്കൊക്കെ അറിയാവുന്ന ഒരു കേസാണ്. Okay, let's say you have a door. നിങ്ങളുടെ വീട്ടിൽ നിങ്ങളൊരു ഡോർ നോക്കുക. അപ്പോൾ ഡോർ നിങ്ങൾ ഇവിടെ ഒരു ഫോഴ്സ് അപ്ലൈ ചെയ്ത് കഴിഞ്ഞാൽ ഈ ഡോർ ഇങ്ങനെ കറങ്ങും അല്ലേ? So that is because ഈ ഡോറും ഇതൊക്കെ കണക്ട് ആയതുകൊണ്ട് ഇവിടെ ഒരു ഹിഞ്ചും ഉണ്ട്. This is what is known as hinge. So hinge ഞാൻ നേരത്തെ പറഞ്ഞു ഹിഞ്ച് എന്താണുള്ളത്. Hinge. Okay. അതുകൊണ്ട് എന്താ പറ്റും? About this point to rotate. It is rotating because this force is causing a movement. അതുകൊണ്ടാണ് ഇത് rotating. So sometimes this occasionally we will call this movement as torque also. Okay. So every time we will not call that, but some occasion we will call this as torque also. Unit of movement is Newton meter or kilonewton meter. Okay. Now, how do you define movement? Movement is basically force into perpendicular distance. Okay. Now, what is mean by force into perpendicular distance? Let's say I want to find moment of this force about this point A. How do I find? Simple. I draw a line. Straight line. Okay, straight line, and I will see force every and a perpendicular right in meeting them. Okay, so this distance I will take. So let's say the distance is A. So this is the perpendicular distance. Okay, so this is a moment at A is equal to F times F into A. Now, what about moment at B? How do you find? Again, you draw a line like this. About this reason. Then this force, I know there is a law of transmissibility, and transmissibility you see here. The force level. Okay, so this will be perpendicular, right? So that distance will be okay. So moment at B is moment of force. Moment due to force at B is okay. So this is how you simply define a moment. Okay, this concept is more or less it's simple. Now this, if you see, to observe it, we know that B is greater than A, and this distance, this A and B, this is sometimes known as lever arm. Lever arm. Lever arm എന്ന് വിളിക്കാറുണ്ട്. Okay, right. So you know that movement at, so since B is greater than A, movement at, sorry, no, since A is greater than B, or B is less than A, movement at B should be less than movement at A. Okay, അപ്പോൾ ഇതിന്റെ ഇമ്പാക്ട് എന്താണ്? ഇതിന്റെ ഇമ്പാക്ട് സിമ്പിൾ ആണ്. നിങ്ങൾ ഇത് നിങ്ങൾക്ക് ഇപ്പോൾ തന്നെ ടെസ്റ്റ് ചെയ്യാൻ പറ്റുന്ന ഒരു കേസാണ്. സോ നിങ്ങൾ അടുത്ത വീട്ടിലെ കഥയിൽ പോവുക. കഥയിൽ പോയിട്ട് യു ട്രൈ ടു ഓപ്പൺ ദിസ് ഡോർ ബൈ പുഷിംഗ് അറ്റ് ദ എക്സ്ട്രീം എൻഡ്. ഈ എൻഡിൽ നിങ്ങൾ പുഷ് ചെയ്തിട്ട് നിങ്ങൾ തുറക്കാൻ നോക്കുക. അപ്പോൾ എന്ത് പറ്റും? ഇത് തുറക്കും. Then again what you do, you go here nearer to hinge and try to push. Then you will feel that ഇത് തുറക്കാൻ എനിക്ക് കൂടുതൽ ഫോഴ്സ് വേണം. I need more force to create. So why? Because this door will open at some moment. So let's say some m dash, some moment ഒരു moment വന്നു കഴിഞ്ഞാൽ മാത്രമേ ഡോർ തുറക്കുള്ളൂ. അപ്പോൾ നമ്മൾ ചിലപ്പോൾ ചെറുതായിട്ട് ഇങ്ങനെ നമ്മൾ തട്ടിക്കഴിഞ്ഞാൽ ഡോർ തുറക്കില്ല. Because it is creating very less movement. ആ മൂവ്മെന്റ് പോരാ തുറക്കാൻ. Okay. Now what happens? If you apply some force here, the force due to movement is this distance, force into this distance. If the same force if you apply here, the distance is less, so that much movement will not be transferred. Okay, അതുകൊണ്ട് you have to apply more force to get to that value. Okay, so we'll talk in some numbers, then you will understand why we have to do that. Okay, അപ്പോൾ simple ആയിട്ട് പറഞ്ഞു കഴിഞ്ഞാൽ, so let us say, so one more thing I will tell. So let's say the force is like this. What if the force is like this? The force is making some angle theta. Just making angle theta. With the horizontal. With the horizontal. Let's say this force is force. What about the moment of this force about this? Okay, so let's say, how do you solve this? This can be solved in many ways. So one way is like this. Okay. One way I can solve this is, I'll drop a perpendicular to this line. Even I'll drop a perpendicular. Okay, I'll measure this distance. So this force I can transfer to this point. Like force I can transfer. You can transfer this because of transmissibility. Okay, so this distance. So m moment at, let's say, A equal to a force times R. So you can do that. Right, that is one way of doing it. So dropping perpendiculars, that is method one. Second method is also simpler method. What you do, instead of doing all this here, you divide the force into two components, which you already know how to do. So this is my y-axis. Okay, so it has two components. Okay, so one is, so these two components I will write as f sin theta is here, and f cos theta is here. Okay, so this is same as if I write it like this. Okay. I'll remove this force completely. And I replace with two forces. F sin theta, F cos theta. F sin theta, F cos theta. Okay. So in the answer, only answer line of action and extend it with perpendicular t distance mark it force into perpendicular distance r. That is my moment. The other way of doing it is second method is you resolve the force into components. Okay, so I did not take A here. So A is here. Okay, now this force is replaced by two components. Now E and component moment about this point. So what is this distance? E distance mark here. So measure this distance. So let's say this A. So moment about A equal to F sin theta times A, F sin theta times A plus F cos theta times. So this cos theta is passing through this point. So the perpendicular distance is 0. Okay, so this is equal to F sin theta times. Okay, so this is another way of doing it. Now, another way is one, we perpendicular distance measure അല്ലെങ്കിൽ നമുക്ക് രണ്ട് component ആയി split ചെയ്തിട്ട് നമുക്ക് അത് രണ്ടും കൂടെ add ചെയ്യാം. ഈ component moment plus ഈ component moment moment. Okay, so this moment is just it's just a property. Move and rotate you can find moment about any point, provided either you know the perpendicular distance to the force, or you can divide the force into two components and you solve. Okay, you can do that. So we'll illustrate you examples in the then you will understand what do I mean by that. Okay, now let's say, so now what I'm going to attempt to say may be a very horrible thing. So ningal ഈ ട്രക്കിലൊക്കെ ഈ KCB-ക്കാർ ഇലയൊക്കെ വെട്ടാൻ വേണ്ടി വരുന്ന സാധനം. Okay, so there could be something like this. The platform down. Then something like this will be there. Then you have a arrow like this. Okay. Then to this arrow, there's a basket. There's a basket. Okay. So you might have seen this in front of now. So there will be keys and all. So there will be one person standing here. Okay. Right? There will be some person standing here. So let's say weight of this person is 80 kg. 80 kg. Okay. And let's say height of this truck is from the ground is center of this person from the ground is this is the ground. Okay. Let's say 2.5 meters, something around that. Meters. Okay. Now height of this point. Let's say it is 1 meters. 1 meters. Okay. Now let's say this distance, this horizontal distance. Let's say it is again. Let's say it is 3 meters. Okay. Now what you have to try to find is you have to find due to the weight of the person. But you can ignore all the weight of this. Weight ignore. Okay, due to the weight of the person, he point at the moment. What is the moment at? Let's say I call this point at A. Okay, I also want to find moment. Let's say moment at a point. Let's say this back tire. This back tire. So this is at a distance. Let's say 2 meters. So this I'll call the speed. Okay. So find moment due to the weight of person. Weight of person. Just give me a moment. Okay. So you have to find moment due to the weight of the person about A and B. Okay. So how do you find that? How do you find that? So you can try. I'll give you 2 minutes. It is fairly simple. It is fairly simple. Try okay. Try then tell me the values. So I need moment at A and moment at B. What is A? A is this point. Is this point. Okay. So you can indirectly say that athro moment this point has to take. Athro moment ആണ് ആ പോയിന്റിൽ വരുന്നത്. അത് എടുക്കാനുള്ള capacity ഉണ്ടാവണം. Okay. So അതൊക്കെ you'll study in further classes. How do you ensure that അത്ര capacity ഉണ്ടെന്ന് ഉള്ളത്. But idea is first you have to see what is the moment and what is the moment about this point. Then we can also see, let's say, so then I'll try you. So meanwhile I'll do something else. Notice in that. So weight of the gauge is 80 kg. 80 kg, you can have to convert to this mass. Okay, this is mass. So that I'll tell you. So this is mass. The weight or mass. Force is basically mass into acceleration due to gravity. Okay, you can take gravity as 10. So that means 800 Newton is the force. 800 Newton is the force. Okay. Anyone? ആർക്കെങ്കിലും കിട്ടും? MB കിട്ടിയോ? ആർക്കെങ്കിലും കിട്ടിയോ? കിട്ടിയോ? Adina,
Yes, sir.
if you are.
Illa.
Okay. So how do you find it? So I'll tell you how to find it. Okay, let's say the weight of the person is acting here. Center. The weight of the person will be acting here at the center of the. So this is 1000. Sorry, 800. Okay, 800 Newton. Now this is 300. So I'll take these 2 points. For clarity, what I'll do, I need 800 also. Yield point. I'll take it. Okay. Now I'll draw the horizontal line. So this is my point A. This distance is given by 3 meters. 3 meters. Okay. So my moment due to A is the force times horizontal or perpendicular distance. So weight is acting vertically down. Distance is given horizontally. So this is a 90 degree. So distance is given, force is given. Only thing is I have to just multiply 800 times 3. That means Newton meter. Okay, this I can also write as, if I divide by 1000, you can write 2.4 kilonewton meter. Okay, Newton, this is Newton, this is meter. So Newton meter and unit. Okay, so that is about it. Now what about this? E point again, I can also do that. So this is there. I'll take this. I'll keep it somewhere else. So let's say. Okay. Now I again take force. My point also I take. Right. I'll use transmissibility to transfer the force. So let's say the perpendicular line we're seeing is line of action of force. Okay. I'll draw the horizontal line here. So these two will meet at 90 degree. 90 degree. 90 degree. So this is 800 here. You can transfer the 800 to here, this point. What is this distance? This is given at 2 meters. 2 meters. Okay. So my MB equal to MP equal to force times perpendicular distance. So what is force? It is 800 Newton. What is perpendicular distance? 2. This is 1600. The unit of this is Newton. This is meter. So that means this is Newton meter. This I can also write as 1.6 kilonewton meter. Okay. We will have to force. This is the movement. Okay. Right. Now you can try this at home. There's a transmission tower. Electric transmission tower. Okay. So this is, let's say this is, okay. So a transmission tower wiring in a connected now. The wire is pulling this with 15 kilonewton. This wire is pulling this direction with 10 kilonewton. Okay. So find the moment due to these two forces at A. So there is a new concept involved here. This we will do in the next class. Okay. Any doubts here? And then a doubt on paper?
Sir, ഇതിൽ നമ്മൾ 2.5 meter height 1 meter യൂസ് ചെയ്യുന്നില്ലേ?
ഇല്ല, നമുക്ക് പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ് നിങ്ങൾ കൺഫ്യൂസ് ചെയ്യാൻ വേണ്ടി ഞാൻ പറഞ്ഞു. പെർപെൻഡിക്കുലർ ഡിസ്റ്റൻസ് മാത്രം മതി. ഓക്കേ. Now, one more small thing that I want to tell you. So this is a concept that we will develop into a concept. The first problem related. First problem, we have seen this that final force നമ്മൾ കണ്ടുപിടിച്ചു അല്ലേ എത്ര ഫോഴ്സ് കണ്ടുപിടിച്ച വാല്യൂ 83.34 ഉം 92.82 ആണ് നമ്മൾ ഫോഴ്സ് കണ്ടുപിടിച്ചത്. Okay, so this point okay, I'll explain this in the next class. Okay, so just give me a moment.